Hello everyone, welcome back to the channel. In the previous video, we have discussed about what is Tesseract and how to use the Tesseract and how we grab the text from the image using pytesseract. So these topics we have discussed. So now let's see how to import the trained data and how to use this trained data in our project. And let's see what is PSM and how to use this PSM. PSM is actually page segment mode. So this represents the document in detail. So for example, we have a document over here. This is in the image format. So this is a paragraph. So, we have to tell this tesseract pytesseract while extracting the data. So how do we need to specify the page segment? So this is a paragraph. So we have to specify the PSM mode to this image to string with the configuration. So it will be easy to the compiler to understand what it is. So let's see first train data and then let's see PSM. So to import the train data, we have to use the open source trained data here. So for Windows we can use this command, and for Mac we can grab like this. So let me first create a test data folder. Mkdir test data. So now, so first I'm grabbing the English one. So it should clone that train data model to this test data folder. You see that in eng dot train data is creating over here. Meanwhile, let me copy this for Telugu also. Okay, now let's download the Telugu train data, and then Hindi. We can import many number of trained languages. I'm importing Portuguese also. So this is how we import the train data. So let's see here how we utilize that test data here with the custom configuration. So I am specifying the custom config, which is my trained data, test data, which is a folder name, and specify which is test data. This test data dir is a command and this is a folder name. Now I need to specify the configuration over here, the custom configuration. Now let's see how it will work. We already have this test03 png added in the image read. So I'm trying to perform. So the result will be remain same, but here we are using the local data using train data models. So these models we can create ourselves. In future videos we'll see how to create a custom configurations, custom train data. So we have ENG and TL Telugu combination of for this image. What it is saying. So I specified 3. So yeah, now you see the data is came correctly. When we paste over here, you will see that it is extracted the data. Uh, this is majorly helpful for us grabbing the data very fast when we use the local models. So let's see what is PSM now. PSM is a page segment mode which tells OCR engine to how to interpret the layout of the image. So for example, this document have one paragraph. This is one paragraph and a single set of unit of a block. So this is stating that it is a single unit, but we treat it as a paragraph. OCR will treat it as a single block of text. So let's see how many types of segmentation modes we have for this OCR. For that, we have to check with the Tesseract help PSM. So you can see that we have 13 types of segmentation modes. So here in the sixth one, you can check it is a single block, stating that assume a single uniform block of text. So this is a single unit block of text. So when we use this PSM with our configuration, so it is easy to get the data fast for the very large documents. So let's see, this is a page book JPG, and here we have to specify PSM 6. So now let's see the output. So it is a Portuguese language, so that's why I specified the language as Portuguese. And we'll see without PSM how the result will come. Result will be similar, but when we give the segmentation mode, it is helpful to the compiler to understand very fast. See, here the data is came exactly, but you see some differences there. Sometimes the data extraction will be done accurate without giving page segmentation mode, but when we give the page segmentation mode, it will extract 100% accurate. So that's why page segmentation mode is very important to extract a document. So here you see several other types is also there. If you see this 7, which is used for a single line. So for example, we are reading a number plate, so that is a single line text. So in that case, it is useful to use a 7. So similarly, other segmentation modes is also there for most of them we use for 6 only, because most of them will have paragraphs in the documents, and 7 is for single line. These two will be major segmentation modes. So now let's see how we bind the bounding boxes for these texts in the image. So the compiler of Tesseract will detect the data using X and Y axes. Using these axes, it will detect the data, and it will bind the bounding boxes over there. So first let's see how this access data will come. So before that, I want to install matplotlib library. This matplotlib library is useful to the bind of images. So now I would like to get this test1.jpg over here. In this, let's bind the bounding boxes. Test01.jpg, and here we no need of the text as of now. I'm just commenting it. We require the result of the accesses. So for that we have one function, image to data, in the pytesseract. Image to data. Now we have to specify this RGB image, and language is Portuguese, and this output output, actually we have to import the output from the pytesseract. From pytesseract import output. So here we don't need to specify this like this. This will come as a dictionary. So now let's print this and check how this result is coming from this dictionary. Yeah, now you see it is printing the details of that all result set. So here you can see left and the top. So these are axes. So from these axes we have to take the data. So you can see the width is also coming and height is also coming. Using this width and height and left and top, we can calculate the axis. For that, now we got the result. So from this result we are getting the length of the result of text, and we have to loop through that in range of n. So here now we have to get the length and width of this data. First I will extract the text of it, result of I dot strip. So this will get the text of this current result for this current iteration. And now if text, I would like to check that if text is not equals to empty, it means we have to eliminate the false positives. So for example, if we have any space over here, so if this is considering this space is also a text, so it will get a false positive. So we no need to bind a box over there. So like that I would like to eliminate the false positives. And now x equals to result of left and top width height. So now it is coming over here. So this is left x-axis and y is top, w is width, h is height. And here we are creating a rectangle with this image. So here if you see, which is pointing the image, and this is a point 1. In the point 1 we are passing x and y, and in a point 2 we are taking the x plus w, means we are adding x. If x, for example, if x is 0, width is 20, so x plus 20 will become that width of that line. So and y plus h means height. If height is 20, y is 0, y axis, so it will become 20 and it will go up like that. So now we have to put the text. So this is going to put the text on the top of the line. Now I would like to show this image. We have created this text and rectangle as of now, but we have to show this image. For that, img underscore RGB, I want to grab into RGB and now show the image. So here I would like to import as PLT. Now PLT dot figure size I'm giving. I would like to give 12 and 8, something to look good, and the image show, this is fine. And I would like to off the axis also, axis off. Let's see how this showing. Yeah, now you see the text is also pointed, and the bounding box is also came here. So this is how we bind the boxes. For example, if I want to add strip length extra, this font I would like to increase, that will be visible to view. Now you can see the font is visible over here, testing OCR. If we don't want to see the data, only if we want to see the boxes, we can comment this line. Now we can see the output. See that text is not there over here.